Hello friends and my dear students, in today's video we'll be trying to classify the organic compounds. We're learning how to classify organic compounds, big group of organic compound into different classes so that we can study them properly, systematically. So how to classify the organic compounds? So if you take all organic compounds, so first of all, organic compounds are classified into two broad categories. What is the two broad category? One is, we classify the organic compounds into two broad categories. One is acyclic compounds. Acyclic compounds. Acyclic means there is no ring. So these are basically open chain compounds. And the other is cyclic compound. So organic compounds are basically divided into two broad categories, acyclic and cyclic. Acyclic compounds are also called as aliphatic compounds. Acyclic compounds are also called as aliphatic compounds. So any compound in which ring is present, that is cyclic. If there is no ring, it is alicyclic or aliphatic compound. Now further moving, this acyclic compound, this acyclic or aliphatic compound is further classified into two broad categories. What is that? One is saturated and the other is unsaturated. Saturated and unsaturated. Open chain compounds, acyclic compounds can be of two types, saturated and unsaturated. We know saturated means there is no pi bond in the molecule. When there is no pi bond in the molecule, it is called as saturated, and if the pi bond is present, it is unsaturated. So saturated compounds have no pi bond, and unsaturated compounds have presence of pi bond. So if pi bond is present, it is unsaturated. If there is no pi bond, it is saturated. We can take simple example like we can have alkane. See, for example, we can have CH3. This is saturated. We can have any alkane without pi bond. It's not necessary to take alkane. We can have functional group, but there should be no pi bond. For example, if we can take alcohol, this is a saturated molecule. Unsaturated, any compound with pi bond, we can have alkene, we can have ketone, any sort of pi bond is present, it is unsaturated. Moving on to next category, cyclic compounds. Now these cyclic compounds are classified into further two categories. One is alicyclic, and the other one is aromatic. One is alicyclic and the other one is aromatic. Now what are alicyclic compounds? Alicyclic compounds, this is combination of two words, cyclic and aliphatic. Means cyclic compounds having properties of open chain compounds, aliphatic compounds. They are called as alicyclic. Actually, we can say alicyclic compounds are nothing but aliphatic cyclic compounds. Aliphatic cyclic compounds. So cyclic compounds have two categories, aromatic and alicyclic. The cyclic compounds which are not aromatic, aromaticity is a set of conditions. There are some set of conditions which make any compound aromatic. So if those conditions are satisfied, the compound is aromatic, or else it is alicyclic. Okay, so alicyclic compounds, we can say they are aliphatic cyclic compounds. Cyclic compounds having properties of aliphatic compounds. Acyclic compounds are called as alicyclic compounds, and other comes into the category of aromatic. For a compound to be aromatic, there are certain conditions required. If those conditions are fulfilled, it is aromatic, or else it is aliphatic. So what are those conditions? First important condition is it should be cyclic. Means we can never call a acyclic compound to be aromatic. It is very important, it should be cyclic. The other important thing is it is planar. The molecule must be planar, and for it planar, what happens is all atoms of ring must be sp2 or sp hybrid. So if all atoms of the ring are sp2 or sp hybrid, definitely the molecule will be planar. And the last condition is it must have 4n plus 2 pi electrons in the ring. The number of pi electrons present inside the ring, it must be 4n plus 2. This rule is called as Hackel's rule. Anyways, in some other video, I will discuss in details what aromatic compounds are, as if now we know very well that benzene is a very good example of aromatic compound, that all we know. So cyclic compounds, if aromatic, they will come here, and others will come under the category of alicyclic. For benzene we can check, like it is cyclic, all atoms are sp2 hybrid, so it is planar, and we can see 2, 2 and 2, total of 6 pi electrons. So 4n plus 2, when we place the value of n as 1, it will total come 6. So it is satisfying all the 4 conditions, so we say it is aromatic. I'll make a separate video to identify the compounds, whether they are aromatic or not aromatic. So as of now, you can consider benzene ring, any compound containing benzene ring is aromatic, or other compounds also which can have these conditions are aromatic, and all others come under the category of alicyclic. Now this alicyclic compound, we can have cyclohexane as example. Now this alicyclic compound can be further of two types: homocyclic and heterocyclic. Homocyclic and heterocyclic. Now homocyclic, what the name is? Homo means same. So if all the atoms of the ring are same, it is homocyclic. If some different atom is present in the ring, it is heterocyclic. For example, homocyclic and aliphatic we have. So we can take cyclopentane, cyclohexane, cyclobutane, anything. This is homocyclic. And heterocyclic, suppose we have some heteroatom in the ring. If we take suppose a 6-membered ring with a nitrogen atom, this is an example of heterocyclic. So this is heterocyclic compound and this is homocyclic compound. Similarly, aromatic compounds can also be having two categories: homocyclic, aromatic, homocyclic and heterocyclic. So best example for homocyclic aromatic is benzene ring, and if we have to take heterocyclic aromatic, we can take pyridine. Similar to benzene, it is, there is a heteroatom, so it is heterocyclic aromatic. Now this homocyclic compound can further be classified into two parts: saturated and unsaturated. Similarly, this heterocyclic can also be classified into two parts: again saturated and unsaturated. Same thing applies. If pi bond is present, it is saturated, it is unsaturated. If there is no pi bond, it is saturated. For example, if we take saturated homocyclic, we can have a 4-membered ring, 5-membered ring, 6-membered ring. Homocyclic, all atoms should be carbon and there should be no pi bond. If we take the unsaturated derivative, make a pi bond. This is unsaturated homocyclic. So saturated and heterocyclic, suppose we are having this compound. This is heterocyclic and saturated, and if you make a pi bond over here, anywhere over here, this becomes unsaturated heterocyclic. Moving to aromatic compounds, homocyclic compounds further can be of two types. Here there's two classes: benzenoid and non-benzenoid. We will discuss in detail about how to identify the aromatic compounds. As of now, we say if in any aromatic compound benzene ring is present, it is benzenoid, and if there is no benzene ring, it is non-benzenoid aromatic compound. So in this way we can classify complete organic compounds. So if let's recall it, if it is open chain, it is alicyclic or acyclic or aliphatic, and if it is cyclic, it is cyclic compound. Acyclic compound may be saturated, If it has no pi bond, it will be unsaturated, it has a pi bond present. Similarly, cyclic compounds are of two types, alicyclic and aromatic. The compounds which are not aromatic, which don't satisfy the conditions of being aromatic, they comes under the category of alicyclic. Alicyclic are nothing but aliphatic cyclic compounds. Alicyclic compounds are of two types, homocyclic and heterocyclic, and again they are further divided as saturated homocyclic, unsaturated homocyclic, saturated heterocyclic and unsaturated heterocyclic, depending on the pi bonds present or absent. Aromatic compounds are classified as homocyclic and heterocyclic. If any heteroatom is present in the aromatic ring, it is heterocyclic. If there is no heteroatom, it is homocyclic, and homocyclic is further classified as benzenoid or non-benzenoid. If any type short of benzene ring is present, it is benzenoid aromatic compound. If no benzene ring is present, it is a non-benzenoid compound.